Galia, oh, wonderful.
Hi everyone. We will start our symposium. So can I share my screen now?
Yes, I can see your screen. It's sharing. Perfect.
Okay. So can we start?
Yes, go for it.
Okay, welcome to Symposium 15 to discuss how functional diversity management can safeguard ecosystems from crossing tipping points. I'm Galia Zelaya, and together with Dr. James Boy, we are going to moderate this session. But what motivated this symposium? Scientific evidence shows deforestation is leading Amazonia to a tipping point, namely forest dieback, and with it, the loss of essential ecosystem functions and services. Amazonia has become a source of carbon emission. Current efforts to stop deforestation are not rendering the expected results, and biodiversity continues to decline. We approach southwestern Amazonia, Madre de Dios, Peru, Acre, Brazil, Pando, Bolivia, known as MAP, as an epicenter of an imminent crossing of tipping points due to continued loss of functional biodiversity in ecosystems. In the region, land grabbing, gold mining, cattle ranching, and agriculture in a weak governance context are powerful drivers, potentially leading to surpassing thresholds and destroying a forest dwelling culture that for centuries helped to conserve forest cover, and with it, his unique functions in ecosystems and services for human well-being. And the question arises, can an in-depth scientific and local traditional knowledge of functional diversity and its functions in ecosystems, economy, and society yield sustainable management prescriptions for achieving resilience across biophysical, cultural, and governance contexts? Well, the situation is complex. We detangle these questions, suggesting a transdisciplinary approach. Today, Dr. Alberto Andrino and colleagues will present a social-ecological system approach as a framework to tackle tipping points and to promote resilience across tipping elements. PhD candidate Diana Boy and colleagues will present findings on soil functional diversity and redundancy in southwestern Amazonia as a basis for science-based management solutions. PhD candidate Malika Pilnik will show the integration of culture and norms of indigenous groups in Acre, Brazil that promotes biodiversity functions and ecosystem conservation. Dr. Regina Schonenberg and colleagues will discuss societal and governance indicators necessary for
Galia, you're muted. You're muted, Galia, for some reason.
Sorry, something happened, but well, please write your questions in the Q&A window, and the speakers will be happy to answer them. At the end of the presentation, we will have closing remarks and a take-home message from Dr. James Boy, co-organizer of the symposium. So we are ready for the presentations. Let's go. Thank you.
Can I ask for the presenters to just turn off their screens, please? And then we will turn it on again during the Q&A. Thank you so much.
Hola, and welcome to the presentation, which will serve as a good starting point to introduce the conceptual framework on which Prodigy project is based. We will guide you through the exciting research framework of social-ecological systems and how we plan to apply it in our project for exploring the occurrence of undesired tipping points. Humanity depends on nature for life support, but human activities are changing ecosystems around the world in profound and uncertain ways. A major challenge of the 21st century is ensuring an adequate and reliable flow of essential services to meet the needs of a growing population. But meeting these needs has resulted in large-scale conversion of natural systems, eroding their capacity to provide essential services to human health and security. Ecosystem services are the aspect of ecosystems utilized actively or passively to produce human well-being. Ecosystem services should not be confused with ecosystem functions, as the first ones derive from the second ones. The functions include the subset of ecological processes and ecosystem structures involving changes in energy and matter over time and space occurring through biological activity. As mentioned earlier, the provision of these services for a growing population has led to large-scale conversion of natural ecosystems, causing significant disruption of the functioning of the ecosystems. Adopting more responsible attitudes to ensure sustainable development of societies should challenge us to work towards systematic approaches based on a deeper understanding of the dynamic interactions between ecosystems and human societies. Major research programs that study global environmental change processes and sustainable human development pathways, such as the Planetary Boundaries, Resilience Alliance, and policy frameworks such as the Millennium Ecosystem Assessment, FAO's Sustainable Development Goals, or the ATBC, allude to the fact that the challenges to ensure sustainable development of societies are best tackled from a complex adaptive systems. All complex adaptive systems share common characteristics, irrespective of whether the complex system is the economy, the internet, the brain, or an ant colony. All of them consist of many diverse and specialized agents, components, or parts in an intricate arrangement. Also, they are usually open systems which continuously interacts with its environment, exchanging information, energy, or materials. Furthermore, they operate far from equilibrium, and there has to be a constant input of energy to maintain the organization of the system. The systems also show emergence. The whole is more than the sum of the components, and the very specific connectivity of each system creates new derived properties. And one example would be resilience, that we will talk later on the coming slides. Another important property of systems are that they are self-organizing. That is, the complexity of the system and emergence increase without an external organizing. This property may allow the establishment of dynamic networks across spatial and temporal scales with interconnectivity, meaning that components of a complex system may themselves be complex systems. Furthermore, the systems may exhibit self-similarity, meaning that the whole has the same shape as one or more of the parts. That is, it has a fractal nature. Neighboring interactions predominate in complex adaptive systems, which can produce feedback loops with negative or positive effects. Relationships within the systems are nonlinear, meaning that the system may adapt to disturbances over time, but when a critical threshold is reached, due to low system resilience, a small perturbation may cause a large effect, resulting in the crossing of a tipping point, where the system may undergo a catastrophic change and reorganize itself into a different state, where a different set of feedbacks becomes dominant, and the system experiences a large, often abrupt change in structure and function. Finally, prior system states may have an influence on the present ones, meaning that CAS may exhibit memory due to the capacity to learn from experience. Therefore, the adaptive capacity derives from the ability to learn and change under the influence of feedback and memory, allowing the system to evolve in the face of perturbation. The application of complex adaptive systems, underlying principles to systems in which people and nature interact, has led to the establishment of social ecological systems. These are interdependent and linked systems of people and nature, which are nested across spatial and temporal scales. This reflects that people are part of ecosystems and shape them from local to global scales, and are at the same time fundamentally dependent on the capacity of these systems to provide services for human well-being and societal development. SES are complex adaptive systems with key characteristics such as self-organization, non-linearity, emergent properties. Among them, we have the resilience. The approach of a SES framework based on complex adaptive systems principles aims at ensuring a sustainable use of ecosystem services over time. This idea of persistence, together with the need of maintaining certain adaptive capacity, has resulted in SES conceptual frameworks aiming to promote resilience for achieving sustainability in relation to uncertainty. Resilience is an emergent property of systems, complex systems, which allows it to adjust its activity and retain its basic functionality when errors, failures, and disturbances occur in the environment. When reviewing the literature, one of the most commonly reported policy-relevant principles for enhancing system resilience is maintaining diversity and redundancy at each spatial temporal scale to sustain an adequate supply of services in the face of disturbances. In a SES context, important system elements that may exhibit diversity include genes, species, landscape patches, cultural groups, livelihood strategies, and governance institutions. While redundancy is closely related to diversity and is a system property that describes the replication of particular elements or pathways in a system, providing an insurance for ecosystem service provision by allowing some system elements to compensate for the loss or failure of others. In summary, diversity and redundancy are important for resilience because they provide options for responding to change and disturbance. These options can increase both the reliability of services and the potential for learning and innovation. In the Prodigy project, we aim to identify potential tipping points through an in-depth understanding of the social-ecological system in the map region, located in the Amazon rainforest. In our framework, we focus on relevant functions for the tipping point dynamic relating land use change and loss of ecosystem services. A better comprehension of map region's social-ecological system functioning will enable decision makers to identify potential pathways towards fostering social-ecological resilience. We hypothesize that social-ecological systems resilience is enhanced through across-scale resilience interactions with functional social-ecological diversity and redundancy being its critical values within and across scales. To this end, we have segmented the map region's system into its interconnected underlying subsystems: the soil ecosystem, the livelihood system, the map region's social system, and the regional climate system. We seek to identify early warning indicators for determining the two system thresholds of resilience: the one between resistance, the capacity to withstand with disturbance and resilience, and the one between resilience and the occurrence of tipping points. To conclude, don't miss the upcoming talks, which will give you a complete overview of the Prodigy project. And thank you for your attention.
Hi, I am Diana.
Hi, my name is Elisa.
I am Renzo Giudice.
And my name is Simona Kilian Salas. Welcome to this talk about unraveling soil biodiversity-driven processes in the Amazonian forest and their impact on society and politics. Today, more than 3 million people live in the MAP region, the three-national region between Peru, Bolivia, and Brazil. Climate change and the growing pressure to extend and intensify farmland are stressing the ecosystem in this region. Increasing storm events, alternating with prolonged dry periods, are a phenomenon already happening nowadays.
What are the consequences from drought and land use change for the soil and the people?
Tropical soil ecosystems are not adapted to long and repeated drought events. I mean, they are able to cope with drought, but have a regeneration period of up to 2 years. So if the interval between dry periods becomes too small, the safety net of the ecosystem, like microbial functionality or water holding capacity, can no longer handle the stress, and the ecosystem could cross a tipping point.
Droughts increase the likelihood and severity of forest fires, which are usually started by farmers and escape further into the forests. Moreover, forests surrounding deforested or degraded forest patches are more susceptible to these fires. As a result, many valuable areas for timber and non-timber forest products, such as Brazil nuts, as well as other direct and indirect sustainable uses, could then be completely vanished as a consequence of droughts, fires, and deforestation. These losses could have a tremendous effect on the well-being of local peoples by potentially reducing their livelihood strategies. In the MAP region, where thousands of households depend on the well-functioning of ecosystem services to secure their livelihoods, this risk is key to be considered for any serious development of coping strategies and public policies. What are the hypotheses and objectives of this study?
Our aim is to test whether soils can rely on a safety net, also called functional redundancy, when facing climate change and the loss of above-ground biodiversity. We hypothesize that microbial functional redundancy and the resilience to cross a tipping point is directly related to the above-ground vegetation and extreme weather events. Greenhouse gas emissions and nutrient recycling can be seen as the measurable portion of redundancy. Therefore, natural forests, which offer highly diverse niches compared to soil under less biodiverse above-ground vegetation, are more resilient to climate change.
We additionally focus on the potential relationship between the loss of forest cover and the loss of soil ecosystem functions, as we hypothesize that the loss of forests triggers negative effects on soil ecosystem functions, which in turn affect the production of forest and agricultural products. At the end, we are interested in nature-human relationships in the MAP region, as the relationship between soils and forests could affect the well-being of the local peoples.
For the field experiments, we work together with local farmers who have gradients of above-ground biodiversity in a small scale, starting from primary and secondary forests to agroforestry to monocultures and pastures as seen in image A. At each biodiversity level, we installed 2 types of rainout shelters. The full rainout shelter, as seen in image B, prolongs the dry season for 4 months, holding back 40% of the mean annual precipitation. The second type, as seen in image C, reduces the amount of precipitation by 40% for an entire year. we sampled soil profiles up to 1 meter of depth for soil and microbial community analysis and installed ion exchange devices to measure the atmospheric nutrient deposition, transportation, and leaching through the soil profile.
Wow, that's quite a plan. How did you manage to work during the COVID-19 pandemic?
Yeah, we were supposed to do periodic samplings at our study sites, but due to Corona, we had to stop our original plan in March 2020. At the moment, we are performing dry re-wetting incubation experiments to investigate the effect of extreme drought on the microbial communities depending on the biodiversity level. To this end, we will analyze changes in enzyme activity, microbial diversity, and greenhouse gas emissions.
And do you have any results of the field experiment?
Yeah, we found that the carbon-nitrogen ratio was significantly narrower in the forest than in the pasture, pointing towards an increased nitrogen input coming from nitrogen-fixing bacteria, which live symbiotically with leguminous plants. Their litter also enriches the forest floor with nitrogen. Consequently, natural forests show a greater ability to avoid nitrogen limitation, while at the pasture, nitrogen limitation will probably be reached easier. Pastures also seem to be prone to cation leaching, as you can see in this graph. Thus, they suffer from potassium and magnesium deficiencies indicated by the cation exchange capacity, which is significantly lower in the pastures.
We performed in the field an additional field sampling along several 300-meter-long transects from primary forests to pastures. We observed a shift of the fungal communities after forest conversion, which could be in future also a natural consequence of drought events. Using LEFSA analysis, we found that the abundance of several fungal genera decreased on the pasture, while Fusarium, a pathogen, increased. However, not only their abundance, also the alpha diversity of fungi was reduced on the pastures, already 5 meters from the forest edge. Fungi are the key players in nutrient acquisition, for example, for phosphorus, which is a major nutrient and hardly available in the deeply weathered tropical soils. This means that on the long run, pastures will run into phosphorus deficiency. So this observed loss in biodiversity could therefore mean also a loss in the functionality.
To test the loss of functionality, we use greenhouse gas emissions as a tool to estimate the functions related to the carbon and nitrogen cycle, and found a strong correlation of N2O and CO2 emissions across the above-ground biodiversity levels. From literature, we know that pastures have a higher decomposition rate of plant residues and soil organic matter, as well as higher fine root biomass. The quality and quantity of carbon sources could allow the dominance of specific species, or at least reinforce the expression of specific functional genes related to aerobic respiration. From literature, we also know that N2O emissions highly depend on nitrogen availability from atmospheric end deposition and as well as from soil moisture. The higher emissions from the forest are the best example of an equilibrated ecosystem, where nutrients like nitrogen can be leached in gaseous form without stressing the ecosystem. The conversion from forest to pasture is a disbalance in the natural ecosystem, causing a shift in the diversity of microbiota while influencing if specific functional genes related to the nitrogen cycle are present or not.
The take-home message could be that we could already detect changes related to different land use histories in the map region, showing that the diversity overall ecosystem levels is connected. We identified changes in terms of bacteria, fungi, plant nutrition, above-ground biodiversity, and gas fluxes. So we conclude that our results are consistent with the fact that changes in above-ground vegetation and precipitation mean real challenges to the functioning of the ecosystems.
We are confident to be able to identify a resilience factor for the diversity in income sources from the economical point of view, as well as the stability of human societies on a larger scale. We consider this to be a very important outcome for governance and management recommendations across all these levels.
Thank you very much for your attention. If you have any question, we will be happy to answer them.
Hello, everyone. My name is Malika. It's a big pleasure to be here with you, talking about functional biodiversity and local stakeholders in Acre, Brazil. Lessons learned and challenges about livelihoods and contribution to conservation. I'm a biologist. I have master in tropical botany, and currently I am working as a social environmental consultant. So, starting our presentation, if we look at these two maps, where the one on the left is of protected areas in Brazil, and the second one on the right indicates indigenous lands, we can see that a good part of the protected areas are indigenous territories. Therefore, it can be broadly analyzed that the traditional indigenous way of life collaborates with the conservation of biological diversity. The whole indigenous land in Brazil corresponds of almost 14% of the national territory. The majority of them are situated in the legal Amazon. Contextualizing this social biodiverse reality for one of the largest remaining blocks of tropical forest situated in the southern western Amazon, which is the map region outlined in yellow on the map on the left, composed by Madre de Dios in Peru, Acre in Brazil, and Pando in Bolivia. And if we take a deep close to the state of Acre, here on the map on the right, we have that almost 50% of the territory is made up of protected areas. From them, 36 are indigenous lands, 19 are protected areas of sustainable use, that is, with the presence of communities such as riverine and extractivist communities, and 3 are units of full protection. In these, there are communities, but the management regime is more restricted. Furthermore, there are overlaps between these areas, which culminates in a series of conflicts over land use. Another important fact is that approximately 85% of the state's territory is conserved. And if we look to the indigenous people in Acre State, we have a rich cultural and linguistic diversity. There are 15 peoples and 3 language families, Pano, Aruac, and Arauá. One of the instruments that contributes to the activities of use and sustainable management of protected areas, especially in indigenous territories, are the territorial and environmental management plans. These can be considered instruments of intercultural dialogue by regulating productive activities in order to establish internal and external agreements, strategies, and goals of good governance practices. It is noteworthy that the state of Acre was a pioneer in the creation of these documents, which are produced in a dynamic and participative way among indigenous peoples, civil society organizations, and public authorities. Briefly, how are these documents elaborated? Workshops are held in the indigenous land based on the methodology called ethnomapping, in which the indigenous people draw the natural resources existing in their territories such as water bodies, game animals, fishing, useful plants, as well as the most vulnerable places where they face invasions from hunters and illegal loggers. A second complementary activity is the survey of fauna and flora species that are both used by indigenous people and threatened with extinction. Based on these information, proposals are discussed for internal agreements among the communities and external agreements with the government and surrounding society in order to improve the territorial and environmental management of these protected areas and to guide how the environmental management should be carried out to guarantee the permanence of these resources for future generations. In addition, this document also includes agreements on other aspects of traditional livelihoods. It guides issues on health, education, territory enforcement, harmonization of land use conflicts, etc. Well, to exemplify an integrated social-ecological system of use and management of natural resources and biodiversity in this region, we approach a case study carried out in the Kaxinawa indigenous land of the lower Jordan River with the Hunikuin indigenous people. The research was carried out using transdisciplinary methods such as focus groups, collective guided trails, which is walking in the woods methodology, and interviews. The study portrays the relationship between the food use of forest and cultivated plant species and the maintenance of agroecosystems through traditional management techniques. A total of 145% food plant species were surveyed, of which 89 are native. Of these, about 60% are managed in backyards, plantations, slash and burn systems, and agroforestry systems. From this data, we infer that these integrated management systems enable the enrichment and conservation of natural systems. At the same time, it is verified that these practices are possible due to the indigenous livelihood and the extensive traditional knowledge that they have built and built over thousands of years. Here there are some pictures of the research and the diversity of food plants. As final considerations, we have that functional biological diversity is conserved in the dynamics of interaction between different native human groups, in our case, indigenous peoples, and that this framework must be safeguarded in order to ensure the maintenance of cultures and the conservation of biodiversity resources. We also conclude that the Brazilian initiative to institute management plans for indigenous lands in an inclusive and participatory way indicates a good path for the conservation of protected areas, and it is important to ensure their implementation through cohesive articulation between communities, public authorities, and organized civil society. Therefore, these experiences can be leveraged into opportunities to exchange knowledge and experiences among communities, both in the MAP region and in other protected areas of Latin America and the world. That's all. Thank you for the opportunity, and we are open to debate.
Welcome to our talk, The Governance of Diversity, Communicating Complex Societal and Legislative Systems to Prevent Tipping Points. This is Oliver Fröhr from the University of Landau, representing the economic work package of the Prodigy project, and Regine Schönberg from Free University of Berlin, representing the social science work package. The further team members you can find below on this slide. So what do we want to explain in our talk? First, we give you an introduction on our starting points. Then we talk about the governance of diversity, access to ecosystem services for whom. We explain our approach towards the entanglement of local systems. We deepen those insights on the hurdles and deadlocks for diversity governance. Then we go into the methods towards co-production of knowledge that we implement in the Prodigy project. So we will talk about participatory scenario building and living labs, as well as how to survey the relationship between ecosystem services, well-being and resilience to shocks of rural households in the MAP region. In the end, we draw our common conclusions. Starting from the question, which prerequisites for good environmental governance and which interfaces would have to be managed in a communicative way to allow expertise having positive effects on preventing tipping points, we try to understand the complexity of intertwined institutions in our research region that are responsible for governance of functional diversity of ecosystems. For this, we need time and resources for communication on the local level, and we will need good science communication towards decision makers to communicate afterwards the results.
We now turn to a central element of our study, ecosystem services. While it is clear that the various types of ecosystem services generate well-being, their contribution to rural households' livelihoods is not equally distributed. Consequently, differentiated information is needed for governing those ecosystem services relevant to people. Since ecosystem services comprise very broad categories, they are not simply governed by one institution, but typically by many different ones. Often those institutions do not know enough about ecosystem services. Therefore, if we want to avoid critical states of social ecological systems, the relevant institutions must be known, and a good communication on the importance of ecosystem services must be established. Our central hypothesis states that there is substantial variation in who is affected critically by ecosystem services, and that this depends on socio-economic and social-political factors.
In this graph, we show you the entanglement of local systems. Additional to the usual ecologic and societal components of a system, we show you the components of the criminal cycles which are present in our research region. Additionally, we have stated some influential factors, such as the history of state formation and of the human-nature relationships in a given system, and the intertwined political, economic, and criminal networks present. So further, we have in orange the components of the societal system, in light blue the components of the criminal cycle, and in green the components of the ecological system. As you can see, and which is not a surprise, everything is interrelated with everything, but what is interesting for research is to see in which extent. So which kind of networks are intertwined with other networks to a certain extent, and how intensive is it? For example, if we talk about public administration, is the public administration more influenced by the legal system, for example, by compliance, or is it more influenced by corruption? In how far the impunity caused by corruption of the legal or economic system is being impacting environmental governance of the ecological system. In how far violence against nature and people is already embedded in the state and in the political culture. Can we talk about state capture, or are there contrabalancing factors in the legal system or in the public administration? So this little graph helps to draw the right question in each new research region we are entering. Thriving for the understanding of complex intertwined institutions and conflicts on the local level, we are confronted with competing elites linked to different socio-economic and cultural reproduction cycles. We observe the repression of civil society participation to different degrees in the different countries. We are detecting on different levels organized crime engaging in drug trafficking and trafficking of human beings, militias in the cities, and gangs and militias in the rural areas, undermining public security and democratic decision-making. On the other hand, this is not counterbalanced with an efficient administration and political will, but with insufficient resources for environmental constituencies and public security due to a lacking political will. To deal with the complexity of the research region and its actors and networks, we implement a whole set of methods towards the co-production of knowledge. So we have participatory scenario panels on the regional and provincial level. We have living labs on the tipping cascade in the natural parks and reserves where we work. There are network analysis workshops, field surveys, focus groups, and the constant will to integrate all the results of those methodologies. Here you can see some images of our regional scenario panel in the MAP region. This is in Rio Branco at the university in September 2019, just for illustration. Summing up the methodologies of participatory scenario building and living labs. Most important, the practice of non-hierarchical and decolonial communication is key. This is what we practice in our project. Participatory scenario building presupposes the co-production of storylines for imagined futures. The degree of depth, complexity, and sophistication of such scientifically grounded imaginary futures are within reach neither of ordinary political and administrative decision makers nor of critical civil society organization. Hence, its production can be very useful if it is being communicated afterwards. The knowledge of the others is meaningful in this context. It is integrated on equal terms into scenarios and represented by models. And the models afterwards are being printed out as maps of the region in 2050. The living labs are transdisciplinary spaces for knowledge exchange by diverse partners on subjects of common interest, meaning the living labs complement those methodologies.
In addition to the scenario panels and living labs, we employ further formats. One are network systems analysis workshops with the relevant experts and stakeholders to identify the critical system components. Based on these, we conduct a representative household field survey to assess in a standardized and quantitative way how ecosystem services, household well-being, and resilience are related in our study area in the MUP region. This information is then fed into the other formats mentioned. Our proposed methodology relies heavily on co-production of knowledge, as was presented in the previous slides. Some formats are more participative and communicative, others more standardized, but together they are meant to be able to identify the critical system components within the social-ecological systems, here specifically for our study area. In relation to the analysis of tipping points, for example, the systems analysis workshops with experts and stakeholders generate input to models with which we derive quantitative indicators for system-specific tipping points. On the right side of this figure, it can be seen how, based on stakeholders and experts' assessments, system components are classified into being critical, that is nearing potential tipping points, or buffering, that is slowing down critical developments. This will be essential information for governing the system. In conclusion, we give a brief account on how we answer our central research question, the prerequisites for good environmental governance and the appropriate communicative interfaces. First, we found that due to the existing diversity on all the levels of social ecological systems, we need to employ a multitude of approaches. Consequently, we opted for incorporating the elements observation, for example, the household survey, interaction, and co-production, that is, the various workshop formats. This said, it is clear that such dialogical spaces require time to allow the highly diverse actors to interact and enable real co-production. Finally, by following this approach in our study area in the MAP region, we experienced that good science communication enables co-produced consciousness on tipping points of social ecological systems, which can ultimately lead to avoid undesired system changes. With these brief statements, we conclude the talk and thank you very much for your attention. We are now looking forward to your questions.
Galia?
Hi, welcome back. Thanks everyone for the presentations and for keep tuned. We are going to pass to questions and answers, and we already have one for Diana it says, is the interaction that exists between different microbes important for managing functional diversity? What is part of your sampling plan?
Makela, thanks for your answer, for your question. This is a very good question. Yes, it is part of our research. Well, I haven't done this interaction analysis yet, but of course we want to see a shift of the microbial diversity in the soil from the forest onto the pasture, crossing the edge, we would like also to analyze their functionality. So I think the plan is that we would like to use this pie crust analysis. I'm not sure if you know it, but you can assign using the 16S rRNA genes the functionality to them, so that we can see afterwards how the functionality of the microbes change. Did this answer your question, Raquel?
I think she can't answer. Yeah. Maybe
Okay.
putting it in the question and answer again. Maybe I might ask a question following this up, because it was also Michaela also asked for the interactions, and you said that the fungi are so important, and probably you can lose some words on the interaction between fungi and microbes, because this was potentially a crucial part, isn't it, of this functional diversity we're after?
Yes, of course, it's a crucial part. So we are basically analyzing both parts, so not only the bacteria, but also fungi. And yeah, but I mean, it's not finished at the moment, so I can't really tell you about our results so far. And also, of course, it's not published yet. But we are about to analyze that, yes.
Okay, thanks. Okay, we continue with questions and answers. James, do you have a questions over there? Or can I go to the next?
Yeah, you can go to the next, of course. I just asked one, so please let other people ask. I mean, it's a symposium, should be at least. Please ask, guys. Fellows and ladies out there, I don't know how many are listening. We receive questions in English, Portuguese, and Spanish. Just give us the honor to ask our presenters something. Thank you very much.
Thanks. So, a question to the whole panel. How people in the map region is perceiving that the tipping point is close, or we already overpassed? It can be to any of the panel or
I don't know.
Please go ahead.
Yeah. Do you know if people can really, according to my records here, there are 40 people listening, but probably they cannot answer like we can here. So let's wait if there's some more questions there, of course. But I think that's exactly the bad thing about tipping points for society. People do not notice because the ecosystems are still functioning like expected. And therefore they hardly believe science if they're talking about tipping points. Therefore, it's very difficult to communicate tipping points to people, because if you cannot notice that something is happening, it's only declining a little and then suddenly, abruptly. I think that's the mean thing about it, because ecosystems have to be and should be resilient, and therefore they're resilient against stress, and then people do not notice that they're stressing an ecosystem and say, oh, it's still functioning. And that's what I think we're noticing. There's a change, but I'm not sure if we're noticing that there are tipping points ahead. And we cannot be sure about it. That's the science about it at the moment.
Yeah, and if I may add, if I'm allowed as a moderator, I mean, it's also often a very slow process. Look at us in Germany here, yeah, not tropics, but we cross several tipping points, but it's over generations, and nobody misses the birds, nobody misses the insects. That's another thing. What might also happen in the tropics, that they probably will forget how lush and beautiful it has been before all this cattle came up. Okay, just a remark, sorry.
Thank you, Jens. Well, I have another one for Regina, talking about governance, and we are talking about map region, 3 countries, a transboundary region. How do you see the reactions of policymakers among the 3 regions in terms of sustainability and environmental management?
The reactions to what? To the transformation of the landscape.
The transformation of the landscape and the tipping point issue and the need of change.
Yeah, I think there is some cooperation So there is this MAP project, a mini MAP project. There are mayors who meet and exchange, but it doesn't seem to be a very institutionalized exchange. I had the feeling that it has a lot to do with personal ties and links, but nevertheless, it is extremely valuable that they agree on certain management ideas. I had the feeling, unfortunately, our field research was limited to 1 year due to COVID. So during those research trips, I had the feeling that local people in their representations, rural syndicates, associations, and cooperatives, that they are very aware of change and that they are really experiences exchange across the borders because they meet and they have value chains, local value chains, so there's some exchange. As far as I know, and what I've observed during our scenario panel in 2019 in Rio Branco, there were representatives of different environmental governance institutions that they didn't know each other because they were standing there and they were saying, it's great to meet you, what a good occasion, and so on. And they started exchange immediately. So I think it would be very important to establish more regular exchange between the environmental governance institutions.
Thank you very much, Regine.
Okay.
I think we are almost close to the end of the symposium. I will invite Dr. Jens to give the final remarks.
Okay,
okay.
I would have had a question for Hermann, but then I see we have to finish that. And for all those who didn't dare to ask questions, I mean, 40 people, I think there must be some. Please send us an email. Yeah, we are here, we're there. I would be really pleased to receive it for myself, and my colleagues are too, I'm very sure. So, okay, closing remarks. It's more than a message in uncertain times. I hope we could transport the idea that diversity is not something we just slaughter down by certain land uses or by fires or by droughts or by whatever, but that it's worth for all of us to fight to maintain diversity for its functions it provides us, and especially that's one of my and our main goals is to make greedy people believe that diversity is something which really pays off for them, which they don't do because it's so nice to have a lush forest, but or anything like that, or that maintain diversity because they do it just for being just for the money. Yeah, we want to prove that maintaining diversity is something which pays off, and I hope you're all, or we hope you're all with us in this battle for a better future, where diversity counts not only among those who care, but also for those who don't care, because it's just simply necessary. And these are my closing remarks. And as said, happy for any interaction. I know it's hard during these virtual sessions, but let's give it a try. Thank you very much, everybody.
One more question.
One more question. Oh, damn. Okay, after the for all, how do we know if we are near to an exceeding? Okay, that was already asked a question. I think that was a return. That was actually already asked. Sorry, Yevgeny. It's people usually don't notice it for the meaning of being too slow in the transition time, or I use Wovo app for more questions there. Okay, yeah.
It's our scientific task. It is hard to find out, but we try to find out.
Exactly. We want
approach it.
We want proxies for this. Yeah, this would have been a question to Hermann because he has some ideas about proxies with greenhouse gas measurement. But now time is over. Thank you very much for attending and have a nice day. Bye.
Thank you very much to everyone. So please keep tuned to Prodigy outcomes in the internet. And if you have more questions and want to address to anyone, just use the WOBA and we will be happy to continue this conversation. Time is over. Thank you very much.
Bye-bye.
Bye-bye.